Hello and welcome to our webinar where we will figure out why cloud computing is more fun with DevOps. Thank you for joining us today, all of you. So, hi, I'm Sasha and I work as a technical communicator and team lead with Artix. My focus topics are cloud computing, DevOps, and container orchestration. I help our customers creating sweet architectures and processes in order to make them competitive. And that's basically my mission. And today I'm joined by Vincent, who I'm pretty sure would like to tell you something about himself as well. So here we go.
Hi, my name is Vincent. I'm also working at Atix as an IT consultant where I support our customers in deploying on orchestrated infrastructure, containerized infrastructure, etc., and automating their CI/CD as much as possible. Looking forward.
Yeah, good stuff. So first of all, before we really dig into the topic, what the hell is even DevOps? So over the years, the term DevOps has constantly evolved, and there are countless ideas of what DevOps really means, and that's absolutely fine. To give us something to talk about today, I'm going to talk about the CAMS model, which I'm pretty sure some of you are already familiar with. And so DevOps, what is it? Actually, DevOps means agile system transformation. But the term was kind of long, so it's pretty hard to use it in stuff like agile system transformation con or agile system transformation engineer. So we shortened it and we call it DevOps. So yeah, and DevOps never meant to exclude stuff like, for example, security or financial. It's more of an inclusive culture where people should talk and be involved early. So for the sake of simplicity today, we will leave out terms of art like biz DevOps, DevFinOps, our end boss, biz DevFinSecOps. Let's just call it DevOps for today, right? So what is CAMS? CAMS is an acronym and it stands for the 5 main principles that play a role in the DevOps context. So it's culture, automation, lean, measurement, and sharing. Let's take a quick look at each of these points of the CAMS model. Culture, for example, a strong DevOps culture fosters collaboration, trust, and open communication, at least between developers and an operations team. It's about breaking down barriers and creating shared ownership of the entire software lifecycle. So DevOps means culture. It's possible that I'm going to mention this a few times during this webinar, because maybe it's a key factor in DevOps success. So by the way, this also includes a clean error culture. Making mistakes must be allowed, and the classic blame game certainly does not contribute to the success of DevOps. So that's the culture thing. Automation. Automation is, of course, also a central element in the successful DevOps units. But automating repeatable processes and tasks can reduce errors and increase efficiency. This includes areas such as build and deployment processes, test automation, and monitoring. That's the automation part. We also have lean. DevOps strives for lean and efficient software development and deployment. This means we minimize waste, continuously improve and focus on what matters most. By applying lean principles, bottlenecks can be identified and eliminated to optimize the flow of our software development. Lean also means that we think about everything in terms of day-to-day operations. Communication and tools are a very good example for this, I think. Then we have measurement, continuous measurement and monitoring of performance metrics is a crucial part of DevOps. By collecting relevant data, errors can be identified and potential improvements and bottlenecks can be uncovered. Measurement helps us to track progress and evaluate the impact of our changes. Last but not least, we have sharing. DevOps encourages the sharing of basically everything. The sharing of knowledge, experience, and tools within our teams and beyond. By sharing best practices, learning together, and collaborating, everybody involved can benefit from the experiences of others and increase effectiveness. So that's basically the CAMS model. That's what a DevOps could be understood as. So,
nice. So after Sasha walked us through the DevOps part of this webinar, I will focus more on the cloud native side. As the DevOps term, it's also hard to find a good definition for it. If I would be forced to find one, I would refer to it maybe as a set of technologies and practices that enables us to develop, deploy, and scale our applications efficiently in cloud environments. So how can we achieve this? The first thing we have always to consider is the architecture of the application itself, because many legacy applications, as you might know, are monolithic architectures where you have like one big Java application that's hard to be broken up into smaller parts. But that's the one really key thing that's necessary to work in cloud environments, because you don't want to scale monolithic applications that have like 10-minute startup time. What you are looking for are microservice architectures where you have like standalone single use parts of your applications that are easy to maintain, and of course quick to start and easy to scale. And it will make your maintenance of your application also a bit easier. What we also utilize a lot in cloud native development is containerization. It plays actually a key part in the cloud native environment, because we are enabled by containerizations to package our applications with our dependencies together in a containerized image. And that way we can deploy on every environment consistently. In that case, it doesn't really matter if you are going cloud or on premise, as long as you have a container runtime that can start your container images. But the key factor on this bullet point is you have consistency across environments, and do not have to care, oh, do I have Java 8 installed on this VM or Java 11, and your application won't work, for example. And another enhancement to containerization is the orchestration of containers. The most known orchestrator is Kubernetes and all its flavors, like OpenShift by Red Hat or Rancher, for example. And why would we utilize orchestration? Orchestration is basically automated container management. You can easily scale containers in an orchestrated environment. And the orchestrator will also take care of load balancing your incoming requests, for example, on the replicated containers. And of course, your containers will self-heal, meaning if one container has to shut down, no matter the reason, the orchestrator will notice and will just restart the container. And if you are going replicated, there's not even a downtime that your customer or your consumer would feel in that way. And of course, what's really decent on orchestrated environments is that you are going for a declarative configuration, meaning you don't have to worry how you really have to do things. All you are telling Kubernetes, for example, is your desired state, for example, 3 containers replicated, and then Kubernetes will take care of letting 3 replicas of your container run in the environment, or the nodes or the resources that are provisioned to it. And the CI/CD, it's like it's also like in DevOps, it's really a key factor in the cloud native environment, because it enables collaboration between development and operations, meaning the work of the developer does not end on their workstation. They are enabled via automated pipelines to push their code in their version control and have the code, for example, built, linted, scanned, and also, for example, built into a container and deployed on a test Kubernetes cluster to test their changes, for example. So they get a feel how their application will not only work in their test IDE, but also in a very similar environment like the production environment they are targeting at. Yep. And that's the four key factors in the cloud native technology. What you are getting as benefits are I'm repeating myself, but the scalability is a key factor. If you have small, fast applications, you are enabled to scale them elastically across your cloud resources, so you can scale down when you aren't needing the resources, so you are paying less. And if you are getting into request spikes, for example, and your applications are scaled fast, then you can tackle that spike. But in the end, you are, or you should be, more cost efficient than if running on like on-premise environment where you have a lot of cold servers, for example, that are not utilized. And of course, in an orchestrated environment, you are mostly, if you want to, high available and of course resilient. As I mentioned, containers get automatically restarted and are very, very, very easy to be replicated. So high availability is more like a standard than a feature in this environment. So now that we learned about the cloud native part of this webinar, let's see how DevOps and cloud native fit together and where the synergies lie.
Yeah, thanks. Let's check out how these two concepts work so perfectly well together. So DevOps itself embraces collaboration and communication. This is something I mentioned earlier, maybe. And this collaboration and communication that is embraced between development, security, operations teams, basically everybody involved. So we are enabled to work together and identify and address, for example, any problems, like, for example, security concerns. And the big idea is to integrate also security into every phase of our beautiful cloud computing journey, from development to deployment to operations. We ensure that security is not an afterthought, but rather a key consideration at every step of our way. That was the wrong key. By automating security testing and monitoring, we are enabled to identify and address security issues early in our processes, reducing the risk of security breaches or vulnerabilities in the long term, which can be pretty expensive. How do we do that? Observability is one of our best friends in cloud environments. We can monitor and analyze cloud environments in real time using tools like, for example, logging. We can use stuff like the EFK stack. We can use monitoring stacks like Prometheus and Grafana. We use stuff like CloudWatch, for example, for our infrastructure. And the third part that we actually utilize is tracing, really important one here. Tracing frameworks like Jaeger or Zipkin help us to really understand what's happening in our infrastructure and in our architectures. So we use these tools to identify issues, including, like I said, security threats, and proactively address them. And since we are all talking to each other, you remember the thing about culture and communication? We actually have the chance to create solutions for the stuff that we address. And that's pretty neat. By using concepts like infrastructure as code, for example, and automation, our cloud environments are also reproducible, scalable, and already built with security in mind from the start.
Time to unmute. Yeah. Also, as mentioned earlier, we are focusing on agile methods in our cloud stack and utilize the CI/CD a lot more than maybe we would do in an on-premise environment. So we are using those to enable our teams to rapidly and, of course, consistently, because pipelines are also reproducible. Yes. So you have like a mint template that you can use across your whole development teams, and in a way also standardize the development, testing, and deployment of your applications, for example. So how do we really utilize those methods? Yeah, of course, when we are developing agile, we are always looking to start small and then iterate. So yeah, like in agile development, you are always looking to build a minimum viable product, and in every following iteration, you add the features to it. And of course, since you are masters of the DevOps culture now, you will also embrace automation and look to optimize your pipeline. So add scanning, add linting, and of course, build your containers in an optimized way, reducing the overhead by therefore optimizing the start time and resource usage of them. Yeah, so the key thing is you want to utilize those methods to enable also your development team to test their deployments for their feature branches on an environment that's, if possible, 100% similar to the environment the application will be deployed in production. So you get a lot more feeling of how do we achieve something as a developer as well when you are involved in those kind of things. And yeah. Thank you.
All right, so that's that. We also have a kind of concept called fail fast and fail forward, because by connecting DevOps and cloud native approaches, we are allowed to experiment and innovate with new cloud technologies and services while minimizing our risks. Fail fast and fail forward is all about embracing failure as part of our processes. Instead of fearing or avoiding failure, we actively seek it out in a controlled and deliberate manner. Failing fast means that when a problem occurs, we want to identify and address it as quickly as possible. This is essential because we'd like to minimize the potential impact of problems and the cost of the failure. By detecting issues early, we can avoid larger and more costly failures downstream. And failing forward is a kind of the second part of the equation. So after encountering a problem, we don't just stop or backtrack. We'd rather like to use our the failure as an opportunity for learning and improvement. We analyze what went wrong, why it happened, and how to prevent similar issues in the future. So this kind of a iterative process of identifying and addressing failures leads to a continuous improvement cycle, making our systems and processes way more resilient and efficient over the time. So we create an environment where we push innovation, risks are embraced, and the fear of failure is reduced. We encourage experimentation and exploration, ultimately driving progress and success. Fail fast and fail forward means to push our teams to their boundaries of what's possible and to continuously refine our processes, leading to more robust and reliable systems in the long run. So that's that. Basically, it's crucial to understand that DevOps is not just a set of tools and processes that we put on top of our cloud infrastructure. It's more of a cultural shift and a mindset that improves collaboration and effectiveness. DevOps does involve automation, but of course, without solely being an automation process like it's seen by many people. Overall, DevOps improves our cloud computing journey by enabling us to develop and deploy applications and services more quickly, more reliable. We monitor our environments in real time, adopt more agile and experimental mindsets, and in the long time, we optimize resource usage and costs and make sure that security is always a key factor that we have in mind. Everything starts in people's mind. It is all in your head. Thank you.
Thank you very much.